Hello guys, this is Saksham Jain and I welcome you all to the Future Camp. So in this video, we will be learning how we can relate our human brain to the concept of deep learning and neural networks. And before that, we will be also seeing, or I can say that we will also be discussing a high level explanation of neural networks. Remember, I said high level. We are not going to dive deep into neural networks. We are just going to just going to discuss just a little bit of information about neural networks so that you can develop intuition related to neural networks. So everything will be covered in everything you need to know about neural networks will be covered in the later videos, where I will cover each and every concept in such a depth that you will be able to understand and implement the concepts right away, and also you will be able to remember everything that I'm telling. And also each and every concept will be implemented using TensorFlow as well as PyTorch, so that you will understand and you will know how to use both the libraries, because it is important to understand and use both the library, because in real life you will be switching between the two. So without wasting any time, let's get started. So on a high level, you can understand neural network system as a black box. If you don't know what is a black box, then you can understand or you can visualize black box as a device or system or an object where you can see what is happening outside the object. You can see from outside what the object is doing, but you won't be able to see the internal workings of that object. For example, this is my object. You can see that what I am doing to the object from the outside, what the object does from outside, but I won't be able to see what is inside of this object. So that system or device is known as a black box. So you can visualize a neural network as a system of black box. But once you get a hang of neural networks and once you understand basic concepts and basic tools, then you will later on understand that neural network system is not actually a black box. You can visualize the neural networks using certain tools, for example Netron, and you can visualize neural network as in form of a chart. But for this level, if you don't know anything else about neural network, then you can feel neural networks to be a system of a black box. So here what I do is I feed some input to our black box and I expect some output, some prediction from my black box. So in neural network, I feed some inputs to my black box and that black box predicts some output. For example, if I'm making a handwritten digit recognition system, then here I will pass on an object to my neural network. It will do some working internally, and after that it will predict what kind of or what digit I have feed to the neural network. So for example, in this case I have written 4, so my 4 will be given as prediction. Another example, for example, I have made a black box that predicts whether the image is of a cat or dog, basically a dog cat classifier. So if I pass on this image, it will do some workings internally, and after that it will give me an output. For example, in this case the image is of a cat. So yes, you can understand neural networks to be a system of black box where you pass some inputs, the neural network does some work to it, and after that I can get some prediction or an output. So if I try to look inside the black box, that how my neural network is working and what are the different parts of my neural network, so you can see that neural network consists, basically a general neural network consists of three parts, which are input layer, hidden nodes and output nodes. There can be multiple hidden layers in a neural network. In this case, this is the input nodes, this is my hidden layer. Here I have taken only one hidden layer, and after that I have my output nodes. I feed my input, I feed my features inside my input layer. The input layer passes the information or the features or the maps to my hidden nodes. The hidden nodes do some computation, perform some calculation on the data received by the input layer. And after performing certain computation, it passes on the information to further hidden layers if they are present, and if not, then to the output layer. So my input layer receives the input layer passes the information to my hidden layers. These lines, the lines that you are seeing here, represents the weights. So what does a weight do? Weight tries to tell me the importance of a particular feature. For example, some features will be more important, some features will be less important. So accordingly, a weight is multiplied to that feature. So if a feature is more important, a bigger weight will be multiplied to it. If a feature is of less importance, a lesser weight will be multiplied to it. So that is the work of a weight. So what does my neuron do? If suppose this is my neuron, it will try to calculate the sum of all the features and weights. And if it passes to a certain threshold, then I will use an activation function here to pass on the information to further hidden layers or to my output nodes. Right now, you don't need to understand the working of neuron. That will be covered in the next video, in the forward propagation video. But for now, you must understand that there is an input layer, there is a hidden node, and there is an output node. So now that you have a basic idea of neural networks, let us try to relate our human brain with our neural networks. So in our human brain, there are several parts. There is a temporal lobe. You can see here in the diagram, there is a temporal lobe, there is a frontal lobe, there is a motor cortex here, there is a sensory cortex here, parietal lobe, and at last there is a occipital lobe. So these are the different lobes present in my human brain. So each part has its own working. For example, my occipital lobe is related to my vision related work. So whatever the things I see, it gets processed inside my occipital lobe, and everything that I understand, or everything that I'm saying, basically related to my language, whatever the stuff, communication that is happening between two people or several people, it is done inside my temporal lobe. And my frontal lobe is basically related to, for example, emotions. My sensory cortex is related to my sensations. My motor concept is related to how my body movements are happening. And similarly, there is some work related to my parietal lobe. So these are the works related to every part of my human brain. If I want to relate my vision related work, so the work of a occipital lobe of a brain is performed by my convolutional neural networks in deep learning. There are many things also other than CNN, for example, transfer learning. Yeah, transfer learning is not a different concept. It is basically in transfer learning we borrow the concepts, we borrow the weights, we borrow the model architecture of a already made CNN network. But yeah, for now you must understand that all the vision related work is categorized as a subfield in deep learning known as computer vision, and the main part of it is called as convolutional neural networks or CNN. The language related work is implemented in the subfield of deep learning known as natural language processing, and there are several things you need to understand in order to understand natural language processing. There are RNNs, encoders, decoders, LSTMs, GRUs, attention-based models, transformers, various type of transformers, BERTs, for example, GPT, DigiBERT, GPT series, etc. So these are all the natural language processing work. For example, chatbot making, parts of speech tagging, and text generation. So all these work is done by my natural is covered in my natural language processing, and it is related to my temporal lobe. If I talk about the frontal lobe, so frontal lobe is responsible for my emotions, and this part of a brain has not been replicated yet in my deep learning. We are still working, we are still trying to give robots emotions, but we are not able to do that successfully right now at present. If I talk about motor context, that is movement, then you can relate it with robots. So there is a company known as Boston Dynamics. You can visit their website. They are making some really amazing robots. So yeah, the work of a motor context, that is movement, is implemented in the form of robotics. If I talk about sensory cortex, that is sensation, then you must be knowing that robots are not able to receive sensations yet. I don't know about the future, but till now this thing has not been implemented yet. And the same case is for the parietal lobe. So this is how you can relate different parts of a human brain with our neural networks, or I can say deep learning. So my computer vision work of deep learning replicates the work of a occipital lobe in my human brain. The natural language processing field of deep learning replicates the temporal lobe. And similarly, the movement related work that is fulfilled by the robotics replicates the work of a motor context of the brain. This is how you can relate the different parts of a brain to the different fields of deep learning. So that was all for today, guys. In this video I gave you a brief intro of neural networks and also discussed that how human brain is related to different fields of deep learning. And in the next video we will be dealing with feed forward neural networks, and in that we will be covering forward propagation. So I will see you in the next video. Until then, bye bye.